Hello, hello class. My name is Pascal. Today I'm going to take you through hydraulic principles. But before that, we are going to remind ourselves what we learned last lesson. Boniface, can you remind us what we learned last lesson?
We learned about force.
Yeah, we learned about force. What did we say force is? Enoch?
Force is a push or a pull.
Yeah, force is a push or a pull. Say that force is a push or a pull. But today we are going to look at something else called hydraulic principles. And these principles works under pressure. Pressure is a derivative of a force. We say that force, that pressure is equals to force over area. So today we're going to achieve some objectives in this lesson. So the first objective is that we're going to state Pascal principle. So by the end of the class, you'll be able to state Pascal principle, then state 3 types of hydraulic systems, and work out one problem under this hydraulic principle. So we're going to state Pascal principle states that Pascal principle states that pressure applied pressure applied to a point of an enclosed vessel or rather fluid is transmitted equally to other parts of fluid. Provided that temperature and other external conditions are kept constant. This is how the Pascal principle states. States that pressure applied to one point of an enclosed vessel is transmitted equally to other parts of fluid, provided that the temperature and other external conditions are kept constant. Yeah. For instance, if you are given a vessel and pressure is applied at this point. Let's say this is a pressure, and you say that pressure is equal to force over area. If you are given a smaller area here as A1, then here we are given A2. So pressure applied at this point will be transmitted equally to the other part of a vessel. So we are going to state 3 types of an hydraulic system. A hydraulic system works under this law, and we are going to look at 3 examples of an hydraulic system. Who can give a trial of one hydraulic system? Yes, Boniface.
Hydraulic pump.
Yeah, we have hydraulic pump. Which other one?
Hydraulic lift.
Yeah, hydraulic lift. And we have hydraulic brakes. So, number one, let's say we have hydraulic pump. Number two, we have hydraulic lift. Number three, we have hydraulic brakes. Yeah. This system works under this law or this principle. Here we say that pressure applied at a point will be transmitted equal to the other parts. So we are going to look at a problem. Yeah, this is a sample. One example. I have an example I'm going to give you to look at it. It says that a machine, a hydraulic machine consists of two pistons. We have two pistons connected by a fluid filled chamber. The small piston has an area of 0.01 meter square, while the larger piston has an area of 0.5 meter square. A force of 200 newtons is applied to a smaller piston. So, if you are given a system, you have been told that you have a system. This is a system, and you have been given that area 1 is 0.01 meter square, and area 2 you have been given that it's 0.5 meter square, and we are told that a force is applied here of a force of 200 newtons. So the question is asking that we are supposed to calculate the pressure transmitted to the fluid. We are supposed to determine the force extended by the fluid on the larger piston. And the last question that we are going to do a maximum weight. This lift can hold. So the first question is, we are going to find pressure that is transmitted to this fluid, and say that pressure is equal to force over area. So the pressure applied is 200 newtons all over area is 0.01. If you do this, you are going to get 20,000 newtons per meter square. So this is question 1. You have answer. Pressure. Question 2 is asking of determine the force here. So under this thing, we are told that pressure is transmitted equally to that. So we are going to say pressure 1 is equal to pressure 2. And pressure 1 is force all over area. And they have been given the pressure 1 as 20,000. You have gotten it. So this is 20,000. But pressure 2 is force 1 is force 2 all over area 2. So force 2, we are going to find it as, if we cross multiply this, we are going to get it. Force 2 as, this is 10,000 newtons. Then the final question is maximum weight of the car that can be held by the lift. So if this is the force, and from the formula that force is equal to mass times the gravitational pull, we have force, and we know the gravitational pull of the earth that are shown to be 10 meters per second square. kilograms per newtons, or rather newtons per kilogram. So force, you have written force to be 10,000 times the mass you are going to find, times the pull is 10. So we divide by 10, divide by 10. We are going to get the maximum mass that can be divided by unit as 1,000 kilograms. Yeah, that's the end of the lesson. But before that, we are going to. So we have looked at the hydraulic principles, and we have said that we have said Pascal principle. We have said that Pascal principle works under that the pressure applied to one point is exactly equal to the other points, and we have looked at types of, for examples of hydraulic systems. We have seen hydraulic pump, we have seen hydraulic lift, and hydraulic brakes. So that's the end of